Hello, my name is Dave Tenney. I'm a product manager with Agilent Technologies. I'm here today to demonstrate new waveform creation software that operates with several of Agilent's function and arbitrary and pulse waveform generators. What I'm going to do today is to create more complex waveform than we did in the introductory video that might be more like some of the custom waveforms that you have for your own applications. This is what BenchLink Waveform Builder Pro looks like when you first start it up. You get a choice of creating a new waveform, a new sequence of waveforms. You can open an existing waveform that you've created or import a waveform from other software in a CSV file format. So again, we're going to create a new waveform. We're using the 33522A function arbitrary waveform generator. In this area now, we can set up waveform properties. I'll just leave this default that's 100 milliseconds with a sampling rate of 1 megasample per second. And that'll give us 100 kilosamples of data points to work with. So I simply hit OK, and now I get a scope-like display where I can begin creating the waveform. So this time, let's create something that's a little more complex that might be similar to an application of yours. So I'm going to select this trapezoidal waveform creation tool. And so let's suppose that you have a device and you're trying to simulate a power-up, a dwell state in the power-up and powering down maybe 1 or 2 times. So let's start with this trapezoid. So the first thing I can do with the trapezoid is to say how many cycles. So let's say 2 cycles. Let's run it for the entire 100 millisecond display that we have. I can set the delay time before I start the power up. Let's set that at 10 milliseconds. I can change the hold time that we're at full power on the trapezoidal shape. We'll set that to 30%, which is 15 milliseconds. I can also change the rise time and the fall time. Let's have the fall time to be a shorter period of time than the rise time. Let's say 2.5 milliseconds. So now I have the trapezoid at the shape that models your power on and dwell condition and power off. Again, I say OK, and now I have the trapezoid on the screen. So before we actually send this to the instrument and look at it on the oscilloscope, let's model a glitch in the dwell state of the power. So the way we're going to do that is to just highlight a few points. And we'll use an editing capability that you haven't seen yet. It's the math functions. And we're going to subtract a DC value from the dwell voltage. And let's have it drop to, let's say, let's have it drop 1 volt from where the dwell is here. Now, in the preview window, it's just DC, so it's not going to be clear at this point to see what this will look like. But we say OK. Now, you'll see that this is a new window. It's a waveform math window. So this is the selected waveform. This is the operation, which is DC. I say OK to that. And now you can see that I have a glitch of 1 volt drop that's in the dwell time on my voltage. So now I have another waveform that's ready to send to the instrument. So I'll go to the communications menu again. In the first video, I showed you how to connect to the instrument. You find the instrument and then actually connect to it. In this case, we'll just send the data to the instrument and then take a look at it on the oscilloscope. So I'll say send the data. I have a default name, waveform 1. I'll just keep that. And you can see that we have the 1 volt glitch dropout in the waveform on every other cycle of the trapezoid. Now we're going to create another fairly common waveform, a multitone signal that's used in communications and audio applications for testing. I'll begin by selecting the waveform parameters again. Let's just leave these settings that we previously had at 1 millisecond duration and a 1 megasample per second sampling rate. Okay, so now we have a new clean screen to begin with. I'll go to the Advanced Segments area. This is the Multitone Segment Creation tool. We'll click on that. You can see that there was already a two-tone signal that had been created in here at a fairly low frequency. So we're going to change this now to a multitone signal. And let's put the center frequency at 100 kilohertz. And let's create 3 tones in this case. Now here you can see I can go to 4 or 5 or 6. So it's fairly flexible here. We'll create 3 in this case. The tone spacing we'll leave at 10 kilohertz. You can see again now in the preview window, you get an idea of what your signal will look like. And you get that, you also see that real time as I'm changing the number of tones. So now we've got the signal that we'd like. We just hit the OK button. And now it's displayed on our screen. We will now go to the menu to send this to the instrument and have a look at it on the instrument and the oscilloscope. So we're in the communications menu again. We select send to instrument. This is waveform number 4. The software sequentially names the waveforms as you create them. And again now when we hit the send button, it will go to the instrument and then show up on the oscilloscope. So we've just finished creating a couple more complex waveforms, a multi-cycle trapezoid, as well as a multitone signal. Hopefully these are familiar with some of your applications. And again, I thank you for watching.